Hi, everybody. This is Slava, and I am super excited for you to join me on this live stream where I answer all questions related to computer vision technologies. I'm excited for you to join for three reasons. Number one, computer vision technologies are the hottest AI technologies today. They are the best and most adapted artificial intelligence algorithms that are being used by companies around the world. Number two, computer vision aims to solve imagery and video problems. And so this is the most relevant, most sort of applicable data that companies are now getting themselves up to speed on. And so as companies create more imagery and video, they are sitting on the oil, if you were, for AI technologies to solve computer vision problems. And number three, computer vision technologies have revolutionized the way people think about automation. And that has led to some pretty incredible transformations within companies and within industries. A little bit about me. I am the founder, CEO of Produvia, and this is a company that has, for the last 7 years, specialized in creating AI technologies to help companies be more autonomous. So I will give you a brief introduction. Most companies struggle to reach full autonomy. Being able to be more autonomous means that companies are able to generate more revenue, reduce costs, and save time when it comes to technologies that can augment and eventually replace certain tasks. So AI technologies are meant to help companies be more autonomous. And this live stream is an educational live stream that helps you to better understand how you would go about using technology to solve computer vision problems. In other words, how you go about using AI technology to solve real problems. In this live stream, I will pick from the community and the audience different questions that I think are worth addressing, and this live stream is meant to be educational for that reason. If you have a question, feel free to post your question below, and I am more than happy to respond. Let's get started. I will, for this live stream, pick audience questions first, and then we can get into any viewer questions that I see. So the first question that I notice is, what is computer vision in artificial intelligence? Anonymous on Quora asks. Anonymous, computer vision deals with imagery and video data. And so AI technology, on the other hand, deals with all data, including imagery and video. And so today's computer vision models really are aiming to use AI technologies like deep learning to solve visual problems, right? So let's think about a few examples of what that looks like. One easy way to think about how you would go about applying computer vision to solve an industry problem is to think, well, imagine we have a picture, and imagine that picture is taken by a vehicle. And imagine in that picture, we see a pedestrian, we see a crossway, we see other vehicles. And so one way you would go about applying computer vision to solve the problem of autonomous driving is you would perform a task called image classification. You would go about understanding what is in that image, classifying that image so that a vehicle can make the decision by itself. It does not require human guidance other than to train the system to begin with. So computer vision models are aiming to solve imagery data. One specific, very popular model that a lot of companies are now using is the image classification. And this allows companies to basically understand what's inside the image, what's inside the video. This is the first question. The second I would like to get into is the concept of Let me see if I can properly make sure everyone will see this question. This is a question that Akash asks on Quora. And perfect. I'm interested in a career in machine learning and computer vision. I'm in my junior year of college. What advice do you have for anyone like me? Akash, there are 3 things you need to do. The first is you need to study biology. Biology, while it may seem a little bit counterintuitive to computer science, it's a critical component of understanding how you would go about simulating intelligence in a computer machine. So you need to study how the human mind works. In other words, you need to study biology. That's the first tip. The second is you need to study mathematics. This is what you would assume if you are to study computer science, which is one of the core areas of study that people undergo when they're pursuing AI specialization. Biology, mathematics. The second thing, rather the third thing you need to do is you need to be public. And part of this sort of effort to put yourself in the public view is you need to, first of all, create a GitHub profile. GitHub is now owned by Microsoft. It is the largest community of developers around AI technologies. And this is a technology that is, at least from the perspective of social network and reach, is the best place where developers can go and expose themselves to outside companies. So the first thing you want to do as a computer sort of science junior in college is you want to create a public profile. And the second part of this public attempt, so this public persona, if you are to become better at machine learning and computer vision, is you want to apply and compete in different competitions around the world. So the second sort of mini tip, if you were, is to apply and compete on Kaggle. Kaggle is a company now owned by Google. So the first link being GitHub, the second being Kaggle. That's Kaggle.com. Kaggle is a great website. Let me just make sure everyone will see that. You will see the link shortly on your screen right about now. So Kaggle is sort of that second website I mentioned to you before. GitHub is that first. In case you are not familiar, please check out both. These are amazing websites that allow you to create a public profile, and this public profile will allow you to get noticed by companies who are interested in talent. So why would you want to be public? Well, being public will allow you to get lots of exposure, lots of publicity around your work, around your interests, and this is how you would go about building yourself. So first thing you do is you study biology, you study mathematics, and then you create a public persona, public profile whereby you're showcasing and sharing your work. So these are 3 sort of pieces of advice. So the next question I see is from Jesse on Quora. Let me make sure everyone will see the same question. And perfect. Jesse asks, I met a PhD student in bioinformatics with a focus on discovering genetic mechanism to curing cancer. I felt embarrassed to introduce my research in deep learning for computer vision since my research does not benefit society much. What should I do? Jesse, this is a question on that you ask, which is something you need to think about. Okay, so I want to remind you that each man walks his own path, right? And so if you want to be okay while talking to others, you must learn to accept yourself, accept your circumstances, right? You are fully responsible for your life. You are fully responsible for the choices you make, and you are responsible for the projects you work on and the types of impacts those projects can have. And so first step is acceptance. You accept your current sort of path. You accept your current impact. Even if it does not have the same impact as somebody else, it is crucial for you to feel like you're doing your best and that you're living up to your own standards. Accepting becomes part of that. And the other note I wanted to mention, Jesse, is that you need to discover your purpose if you feel misaligned with the impact you're making. So start with the impact. What kind of impact do you want to make? Right? If you're not being impactful enough, you have to ask yourself, how can I reverse engineer to who I need to become? What is my purpose in life? So start with the impact, work backwards. Perhaps your impact is to create a more social benefit. And so now you need to ask yourself, what can I do? Perhaps what project can I work on? What algorithm can I develop that allows you to contribute to the world in a more meaningful way? So Jesse, you must learn to accept yourself. And more importantly, if you have not discovered your purpose, you must do so now. That way you can live your life without feeling regret or without feeling angst when you're talking to somebody who is doing something different. Perfect. The next question we see is, I have Clayton, and Clayton asks, what would be, let me make sure everyone will see this, what would be the best job title for somebody that deals with computer vision and deep learning problems? Clayton, this is really a question of naming, but nonetheless, naming is one of the hardest tasks when it comes to programming, and all engineers are often joking in that naming things sometimes takes longer than writing code, but I digress. Computer vision engineer is the best title to create for yourself if you want to solve computer vision problems. Practitioner, developer, specialist are all other types of descriptors you can use for yourself, but I would say computer vision engineer will get you the most attention, the most reach, the most understanding. Now, deep learning engineer is the next best title for you if you want to be solving deep learning problems or you want to give a focus on deep learning technologies. Computer vision engineer or deep learning engineer. It really depends on what you focus on. But I want to emphasize here that, Clayton, if you want to do both, if you want to be a computer vision specialist or practitioner and be seen as a credible deep learning researcher or developer, then you must incorporate both, right? Now, you could go higher level. You could say, I am an AI engineer, but I would say that being specialized is a good thing. So what you can say for the third option, whereby you're looking at sort of specializing in both technologies, you can say that you are a computer vision based deep learning engineer. I know it sounds crazy, but I think it's totally applicable in your case because you want to do both. Now, computer vision based deep learning engineer or deep learning based computer vision engineer is the same thing from my perspective, but feel free to use either if you do want to go down that path. And let's see what else we got here. We have a question from Anonymous. Anonymous on Quora asks, I am learning computer vision and feeling overwhelmed by the amount of things I don't understand. What should I do? Well, Anonymous, any new subject will seem hard and overwhelming at first, any new project. So how do you get past that imposter syndrome? How do you get past the information overload? There are several ways to do so. The first way is you must recognize that as a beginner, you will stumble. You will fall. You will be awkward. You will not know the latest terms. You will not know the latest techniques. And that's okay. First step, you're a beginner. You must lower your expectations. You must lower your standards as a beginner. Now, as you improve, as you get more comfortable with the technology, with the lingo, with the programming languages, with the algorithms, with the models, now you can start to raise your bar, right? You can now start to set higher standards for yourself. You can now start to increase the challenges that you take on. And the best way to take on these challenges is to do the following. Step one, you must learn something new. Step two, you must take a break. And step three, and final step, you will repeat this cycle. This is the recipe for success. Learn something new, take a break, repeat this cycle. This is a cycle that will repeat itself no matter what you learn, computer vision or not. And learning something new means you can now increase your skills, and ultimately being able to be better at what you do means you can earn more money, have a bigger impact. So if your goal is to be less overwhelmed by computer vision, the first thing to do is to take on a new challenge, learn a new skill, take rest, and repeat. I want to emphasize rest is super, super important when it comes to learning. Rest is how you go about incorporating what you learn into your short-term and eventually long-term memory. You need to take a break because it allows you to recover or rest enough so that you don't overwhelm your mental or central nervous system, right? Recovery is key, and being able to recover your mind from learning something new is how you would go about retaining that information. The second way you would go about not being overwhelmed by what you're learning is you need to understand that you are overwhelmed because the subject is new. And so the way you would go about it is you would need to take down you would need to think from the perspective of being a deductionist, a person who deducts or breaks down complex topics into smaller, simpler components. The second thing you do is that you simply need to reduce the complexity of what you're learning by relating what you learn in simpler terms. This is the infamous Richard Feynman technique. For those who are not familiar, Richard Feynman is one of the best physicians of the previous century. He has helped revolutionize the way that the complex topics were taught in universities. He is one of the founding fathers of quantum computing, today's one of the most powerful technologies that are being developed in countries and companies around the world. And he has a very simple strategy. The way you teach is by reducing complexity. You make things simpler. You reduce a complex topic into simpler mini topics. This is how you go about teaching somebody. This is also how you go about learning something new. If you're feeling overwhelmed, you either need to increase your skills or reduce the complexity of what you're learning. Two simple strategies that I think will go a long way. So this is a very important reminder. Next question I see is from Sean, and Sean has a question on Quora. Let's make sure everyone will see that. The long one. Okay. So everyone will see this question right about now. Perfect. Sean on Quora asks, what is the difference between a neural net for object classification and a neural net for obstacle avoidance? The same video image data is used as input into both neural networks. So how do the neural networks know what outputs you are looking for? Sean, this is a great question. So a couple things I wanted to make clear for those who are not familiar. Object classification is a computer vision task. That's step one. On the other side, we have object avoidance is a reasoning task. So that's sort of step 2. And at the moment, they're not necessarily related, right? So one aims to look at visual data, one aims to interpret visual data and make a decision based on that data. But you do need both if your goal is to do object avoidance. So let's break this down. Object classification. What is it? It's a task that involves analyzing visual data and arriving at a conclusion using probabilities. Right? Decision making, on the other hand, is a task that involves analyzing data of different levels of abstraction from separate sources with different levels of certainty. Merging that information by weighing in on some kind of a data source, more than one, hopefully, and arriving at a conclusion by exploring all the possible options. Right? So we're talking about reasoning on one side, and we're talking about understanding on the other. First, you need to understand, then you need to reason. So it would go. The sequence and the difference between them is that object classification is usually done first, then we get into more advanced problems like object avoidance. So hopefully that answers your question, Sean. I appreciate the question. So the next question I see is from Ed. And Ed on Quora asks, why is the human brain so good at facial recognition? Well, let's think about this, Ed. Human beings have evolved to be social, right? As the result, we've learned to look at faces because that's how we understood the world. The facial expressions and facial emotions of people who were next to us were how we learned to interact, how we learned to communicate, how we learned to learn about the world. So the human brain was designed for facial recognition because we needed to better understand social status. So let's think about this. Social status is a game we play that is very synonymous with the concept of hierarchy, right? You understand that usually there's a person, for example, within a company who is at the top. There are usually managers or directors on sort of the next management tier. And then after that, we have sort of the co-directors or perhaps the supervisors, primary managers, and then eventually you have the frontline workers. So in a hierarchy, we have a series of organizational ladders, if you were, and this hierarchy is very important in the context of sort of a prehistoric human. We looked at each other and we mentally created hierarchies in our minds about who the tribe leaders were, who the tribal members were, and more importantly, who was not part of that list, right? So there are people who are strangers, and we would use faces. We would understand faces because we needed to know who was friend from foe, right? Fight or flight. And our ability to understand faces, our ability to understand whose face we're looking at, was driven by the fact that we lived in small cities and we needed to understand elders and social hierarchies. And this actually leads to the next question, which is how to thwart facial recognition and other surveillance. So Mohammed on Quora asked this question. Mohammed, how do you go about fooling facial recognition software? Well, it's possible. With technology, like I say, anything's possible. It's just a matter of figuring out how. So how do we go about throwing AI systems off their track? So facial recognition, for those who are not familiar, is recognizing faces using computers. Like we've talked about in the previous question, facial recognition can be done by us people. We use our eyes, use our minds to understand who we're looking at, to understand if they are a friend from foe, if they are somebody who we've talked to before or not. And we can have a computer do exactly the same thing. Human recognition or computer vision driven facial recognition is basically the same thing. One is biological, one is electronic. So why do we need facial recognition? Well, let's sort of take a back step here. Facial recognition technology is needed because we need to be able to survey or monitor mass populations at any given time, right? Imagine we have a crowd of people walking by a checkpoint. Imagine we have a sensor that or rather a camera that's able to detect people's temperature. Now you can have mass surveillance of individuals walking by, and you can do mass COVID-19 pre-screening using temperature. Think about that. Computer vision is now sort of solving COVID-19 problems because we're now able to understand people's temperatures. So this is an application of computer vision. How do you go and fool these systems where they're recognizing faces? Well, you have to understand that most of these AI systems, most of these facial recognition and surveillance software have been trained on faces. And most of these faces do not have glasses, do not have a hat, do not have masks, do not have anything visually obstructing their view. So how you would go about fooling them is you need to wear a mask, you need to wear glasses, you need to wear a COVID-19 mask, you need to wear something that blocks the camera from looking at you and seeing your full face. And it's very easy to do so. It's very easy to fool the latest AI systems, but there are many ways to go and fix that. So if you're interested to learn how you would go about improving facial recognition software, I'm more than happy to dive into this, but that's for another topic, another day. So to keep it short and to the brief, you would fool AI-driven software that's recognizing faces by putting something on your face, right? These systems are scanning your face, and if there's something there the system has not seen before, you can almost predict, at least in the short term, that the system will not work. And I want to make sure that you understand that as data is collected over time, right, as data improves, you are able to see more and more of that data. And the more data is built, the more data is collected, rather, the higher the probability that these systems will be trained to understand faces, even if there are obstructions on the way, even if there are obstructions on the face. Meaning, if a person is wearing a COVID mask, AI systems can still be trained. They can still be effective. You just need the right data and trained in the right algorithm. And let's move forward. The next question we see is from David on Quora. David asks, can face recognition software tell if a photo has been edited? David, yes, it can. But there is that but. You need to know if that system has been trained on the task of image manipulation detection. So yes, but it must be more complex. If the system is simple, if you're looking at recognizing faces, you cannot detect if a face has been edited. But if your goal is to understand sort of the concept of a fake image or fake video, then you must train an AI system accordingly. You must train a system to understand fakes, and that means you must give it examples. You must train through supervision of what it means to manipulate images. Right now, there are models today, there are algorithms today that individuals use to understand if images have been manipulated and being able to detect those manipulations. But that's another question, another day. I encourage everyone to ask really deep, really detailed questions about AI. I'm more than happy to address them during this and upcoming live streams. The The next question comes from Alian on Quora. Alian asks, what are the limitations of digital image processing? Alian, there are lots of limitations. So let's think about this. Digital image processing requires lots and lots and lots of data. So we're talking about not just 10, not just hundreds. We're talking about thousands, and even more preferably, millions of images that you need to train these systems. Image processing means you're processing image and you're extracting information. So let's talk about a few examples. So what's happening today is that more traditional image processing systems, they are done manually, right? And I'll give you a few examples. Manual image adjustments, manual image transformation, manual image segmentations, feature detection extraction, and image restoration. These are just a few examples of what's necessary to process images. Most of these tasks are solved manually, right? Programmer is explicitly defining if-then statements. They are explicitly creating the algorithm that you need, and that algorithm must run exactly the same way. And you can already see the limitation. The limitation is that a person is necessary to write these algorithms. A person, not a bot, is necessary to handcraft features. As soon as you want to achieve more autonomy, now you are able to bring in robots. You're able to bring in software that can do this on the practitioner's behalf. So what does that mean? Imagine guiding the computer to create and explore 10, hundreds, thousands of features that are needed to understand images. Guiding the computer to automatically perform feature extraction based on images. This is the holy grail, right? This is why companies today are making billions of dollars on AI technology, is because there are now algorithms that are able to do this. There are now algorithms that are automatically understanding what's in that image and how the information from that image is useful. This is deep learning. This is deep learning-based computer vision, and it is by far the hottest area of research around academia, around industry, and generally around consumer interest. This is a big one. Kenneth, we have a question on Quora from Kenneth. Kenneth asks, which OCR technology is the best? Kenneth? For those who are listening, OCR technology is short for object character recognition. Object character recognition is the idea that you're able to recognize characters from a visual data source. So imagine you're looking at a picture, that picture has words, pictures, and that picture has words that mean something. Well, if you're performing OCR, I mean the visual elements that are related to text and you're making sense of them. So if that picture contains a word or a sentence, OCR would then go about extracting the text from that image. So now OCR technology can understand the written word within imagery, right? This is amazing. Right? If you're able to understand the written word, now you can put more advanced technologies to use, right? You can apply natural language processing, or NLP for short, and now you can make meaning from the characters that are being extracted from visual imagery. So the typical workflow is you go from OCR technology to deep learning. You go from understanding the characters, understanding the text, to making a better understanding of what that means, right? OCR, NLP. is usually the path that companies take to make sense of textual data. So visual textual data, super, super important, because we have a context where today we have millions of companies sitting on traditional paper, right? They're practically printing paper and they are storing that paper in a very traditional manner. Traditional meaning non-digital. So if you have companies storing a physical record of anything, right? Work order, accounting, receipts, etc. Well, how would you go about creating more autonomy? How would you go about creating a company that does not require any paper? How do you achieve full autonomy and have zero paper? That's possible using OCR technology. So the question then arises, what's the best technology, right? And I briefly alluded to this, but deep learning based OCR models are by far the best technology that we see today. Now, there are many projects that aim to solve OCR. A very good example is Tesseract. I believe it's spelled and let me make sure that I get the name. Tesseract. 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 This is a open source software that is now maintained by Google, written by Google as well. And Tesseract is using computer vision, more specifically using deep learning technologies to make sense of visual data. OCR technology is by far being sort of improved to the point where now systems are able to outperform people. They're able to outperform performance of understanding of individuals who are looking at imagery with text that is hard to read. OCR systems are now better, and the reason they're better is because they're able to use deep learning technology. So to recap, the best technology is the technology that uses deep learning or neural networks. Tesseract is one example of that. And what I'll do now is I'll simply share with you the link to the Tesseract that I've mentioned to you on this live stream. And Tesseract is that one open source project now developed by Google. Tesseract, Tesseract rather. Okay, perfect. So the next question that we will address is from Cassandra. Cassandra on Quora asks, do you think that Amazon's facial recognition technology will make life better or worse for people, and why? Facial recognition software is really software that aims to understand and detect people's faces. So imagine you have a video, and perhaps it's a video of a household. Well, when you have a person walking by, the Amazon's service will now be turned on, and it will understand that a person walked by. Right? It will recognize that there's a face in the frame, and that face will have a box. Hopefully that shows up like you see on my camera here. Perfect. This is how you would see the response of a facial recognition software. You simply create a box around the person, and that box is indicating that, hey, there is a person, and that person has a face in the frame. Super important for lots of applications, including surveillance, right? So the question then becomes, what do you think about Amazon service, and how will it make life better or worse? Well, I think there are really a neutral way to apply technology. Think of sort of the applications as a spectrum, right? So on one side, you have the best case scenario, good use of AI technology. On the other side, you have sort of poor use of AI technology, or misuse, if you will, right? So we're talking about a spectrum of applications. And let's talk about sort of the more positive applications first, and then negative. So on the positive side, AI technology that's understanding faces is able to create more safer public and private spaces. More safer. Understanding that people are moving through a space, understanding, detecting their faces means that there is potentially less crime. There is more supervision, which means safety is now increased, right? Perhaps it's a mining site, perhaps it's a industrial site. If you're able to detect people's faces, perhaps as it relates to other autonomous vehicles, now you're able to prevent accidents. On the positive side, facial recognition software, whether it's by Amazon or any other company, is able to make things better by increasing safety. On the other side of the spectrum, we have the bad use of technology, the misuse of technology, the misrepresentation. And here we're talking about using technology to spy, using technology to reduce the privacy, again, in both public and private settings. Reducing privacy means you are infringing on people's rights. You are infringing on people's sort of personal and physical and digital space. So one way to misuse technology is to spy or do surveillance on individuals, whereby you're limiting their privacy. Ahmed on Quora asks, what are the applications of edge detection? Ahmed, thanks for the question. Okay, edge detection, what is it? Edge detection is basically image processing technique, which involves computing an image gradient to quantify the magnitude and direction of edges in an image. Image gradients are used in various downstream tasks like computer vision, such as line detection, feature detection, and image classification. So, in other words, we need to understand the edges. So it's a stepping stone for other tasks, right? If we're detecting where a line is that separates a person from a vehicle, well, you need to know the edge, and you'd go about creating an edge first before you would go about creating a line, right? So this is a simple example. Great. And the next question comes from Christopher on Quora. Christopher asks, what are the current topics, or rather, what are the current hot topics in computer vision technologies? Christopher, there are actually quite a few trending topics. Hot is usually trending, so I'll stick to the sort of the trending side. And when I say trendy, I mean I have seen a research project that has picked up community interest. It has picked up interest from companies and other stakeholders who are curious to know how you would go about creating a more remote-friendly video conferencing setup. So what does that mean, right? Let's say we are at a meeting. Let's say it's a digital meeting, a remote meeting using Zoom. Well, perhaps a few of the individuals who are joining that meeting are joining from a place where there's lots of background noise, right? Behind me, you see a pretty clean, pretty clear environment. For the most part, it's simple. You know, we see a plant right there, my chair right there, and myself in the frame. But some settings, some home environments are quite messy, quite cluttered. Some are not conducive to video conferencing. And so the question then arises, how do you go about using computer vision to make remote conferencing more professional? Today, this is a task for something called image matting. matting, that's M-A-T-T-I-N-G. Image matting is a process of basically accurately estimating the foreground object in images and videos. It's a very important technique in image and video editing applications, particularly in film production for creating visual effects. So in case of image segmentation, we segment the lines of the image into foreground and background by labeling the pixels. Image segmentation requires a binary image in which the pixel either belongs to foreground or background. However, image matting is different. Image matting is different from image segmentation because some pixels may belong to foreground as well as background. These pixels are usually called partial or mixed pixels, right? So, if my hand is in the frame, well, in between my fingers, you see the plant, right? And as sort of software is learning to differentiate between the two, well, it's not enough to just detect the plant or my hand. You need to be able to detect pixels that are sort of blurred in between, right? That are applied to both my finger outline and the plant outline. So image matting is different than segmentation because image matting, you're using partial or mixed pixels. What that means is, in order to fully separate the foreground from the background, accurate estimation of the alpha values for partial or mixed pixels is necessary. Alpha values are basically image spectrogram values. So recently I've seen a research paper which is just really mind-blowing. What I'll do now is I'll quickly Google it on my computer and pull up the research paper so everyone will see. And I'll also do a screen share. And hopefully this makes the live stream rather, more interactive. And on the live stream, you should see right about now, side by side of my screen, it is real-time high resolution background matting. So let's bring a spotlight to this particular live stream, screen share. This is an amazing research paper that came out only recently, December 14th. It's called Real-Time High Resolution Background Matting. And I really love this research paper for a couple of reasons. One, it's freely available. Anyone can read it. Anyone can learn to apply these concepts to create basically background filters that aim to be helping video conferencing software look more professional, look more accurate. So here's a brief example. On the left, you have a Zoom call of an individual who's sitting what it looks like a typical house environment. They're actually sitting next to their kitchen. You can see that there are elements that are behind them that are being captured of their personal space. Now, the image in the middle is showing you that you can actually have an individual be on a different background. So this is where Zoom is using a traditional or standard wallpaper. Think of it like applying a different wallpaper, thinking that there's a green screen. So now we're applying a different image on the background. But you notice that we have the person's sort of mixed pixels not working as expected. You have the hair follicles, and they're still showing the old background image, right? And that's a big problem, right? It creates an unrealistic background that already gives sort of the Zoom call less professional look, right? Same thing happens with the individual's sort of frames for their goggles and glasses. And the same thing happens because these images have been trained on image segmentation primarily. This is what Zoom is doing today, unless you have this new technique. And here the authors, you can see them from Washington, have applied a new method to basically create a system that can also incorporate mixed pixels and learn how to differentiate a traditional pixel from a mixed pixel, and then learn, more importantly, to apply the right background and make sure the foreground stays untouched. So the first reason I like it is that this project is getting a lot of attention. And the second reason I really like this project is because it's actually open source, right? So open source projects are an amazing way to go about applying AI technology and solving real problems because they are freely available, right? Okay, let's think about this. Let's jump into our screen share here. You'll now see side by side and a focus on the official repository for this project. Background matting version 2 is the name, and it is definitely getting my star and a custom watch. Perfect. So let me make sure that I can see any new releases happening on this project. You can see the open source code here. It was released actually only 3 days ago, so it's quite impressive, and you can see that it's possible to make videos really, really powerful by extracting the background and imposing a different background. So this is a research paper. The research paper has open source implementation, and this research paper is freely available for anyone to use and apply in their own context. This is mind-blowing. Being able to create super high realistic, real-time sort of videos that are being manipulated by computer vision technology is truly groundbreaking. And being able to do so at a high frame rate, being able to do so at 30, 60 frames per second or higher is truly incredible. Being able to do so while maintaining accuracy is mind-blowing as well. So I highly encourage everyone to check out image matting. It is the hottest, most trending computer vision topic that I see today. Mind you, there are actually quite a few. I did a quick search and I found 24 different papers that have gone to solving this particular problem. Lots of research, lots of interest from academia and from industry who are trying to solve this. Zoom is a perfect example of a company that's looking to leverage this technology. But you can also look at film production. They're quite interested in this as well. So many of these research papers that I've mentioned to you, the 24 count, are open source. They're available at least for interpretation. You can go and find the research papers and read more about their methods, so you can then apply the technology yourself. So this is a great way to finish this live stream. I want to give you a little bit of context to myself and conclude this live stream by emphasizing that I have been in the AI space for the last 8 years, and I have seen technologies come and go. Computer vision is one of those technologies that has stayed around and, in fact, has been the most prosperous and most developed area of research. This is a technology that now companies around the world are using to create new solutions that are creating massive value for the companies that are using them, for researchers that are applying these technologies. Computer vision technologies are the best way to get into AI by far. If you have imagery data, if you have video data, or if you're looking to get into the applications of computer vision, now is the time to start. Now is the time to schedule a discovery call with me, and I am more than happy to discuss with you how you would go about leveraging computer vision to solve real problems. Right? Computer vision is not something that is often intuitive. It is not something that is often understood from the first glance. but it is a powerful technology that requires careful planning. It is a powerful technology that requires implementation. And if you are interested to use computer vision in your project, in your company, in your team, I highly encourage you to schedule a discovery call. Link on the live stream is below. And what I'll do is I'll also send you a link in the chat. And that way you can always click on the chat and you can see and click on it and go from there. That way you don't have to type. Hopefully that saves you time. So to recap, AI is an amazing technology. It has truly revolutionized how people solve imagery and video problems. And today there are many problems that companies are now solving. AI technology is moving very fast. It's very powerful, and it does require expertise. And I'm more than happy to chat with you about what are your next steps in how you would go about using computer vision technology. So whether you're looking for strategy, whether you're looking for research, whether you're looking for development and implementation, my team and I will help you to get your solution to the next level. It'll help you scale, right? So the real question you have to ask yourself, like, are you looking for revenue? Are you looking to decrease costs? Or perhaps you're looking to save yourself time. Then full autonomy, more autonomous solutions that use computer vision problems, computer vision technologies can be developed. And I'm more than happy to chat with you about how you would go about doing that. I am super thankful that you've joined me on this live stream. We've been talking about computer vision for the last hour. I will give you time to reflect back on yourself. I challenge you, this is my challenge, to think about what is the problem that you can solve using computer vision. What type of data do you have? If you don't know the challenge, start with the data. If you don't have the data, start with something like the ability to make an impact. Start with the impact, start with the data, start with the challenge. I challenge you to think about how you go about using computer vision. And if you need help in figuring out how you would use the technology, I encourage you to reach out and schedule a brief call with me. I am super excited that you joined me. I want to thank you for your time once again. And I am doing an upcoming interview tomorrow at 2 p.m. Pacific, 5 p.m. Eastern Time. Myself and another founder are talking about how you would go about disrupting the banking industry, the banking infrastructure, using the latest technologies. I am pumped about this particular interview, and the founder of MOV will share with me how you would use technology to solve real banking problems. Super excited, super stoked. I hope you join in for tomorrow's live stream at 2 p.m. Pacific, 5 p.m. Eastern Time. I will continue live streaming on the topic of AI technologies next week, so I highly encourage you to subscribe, hit the bell icon, and I am looking forward to answering your questions next time.